Hi class, we're still in our notes from 10.6 day 2. We're on the back page now doing 4, 5, and 6. The first three were exponential growth problems. As we read number 4, look at what we have here. HTI bought a computer for $2,500. It is expected to depreciate at a rate of 20% per year. What will the value of the computer be in after 2 years? So in this one, it is expected to depreciate. That oftentimes happens with technology. If you think about like an iPod that comes out and you buy it right away, after 1 year that iPod isn't worth as much as it used to be. Technology really depreciates very quickly. The same is true of this computer. So if it depreciates, that means we're talking about decay. And if we're talking about decay, our rate is going to be a number that is less than 1. So keep that in mind as we do this one. So we still have y equals AR raised to the t. So in this one, A is our initial amount. HTI bought this computer initially for $2,500. So $2,500 is our A value. Our rate, what is the rate of increase? It says it depreciates at a rate of 20%. Now this can be kind of confusing because people want to put 0.2 right here, which is incorrect. The reason for that is because it depreciates at 20%. Okay? So the R value is what does it increase, the rate of increase. So just as we added the rate to 1 for our growth problems, what we're going to do here, class, is we're going to subtract it from 1 with with decay problems. So 1 minus 0.2, which is 0.8. In a way of saying that, if it loses 20% each year, it still retains the value of 80% of the computer for that year. So its rate of increase is 0.8, which is still a decay problem because 0.8 is still a number that is less than 1. So it has 0.8 for an exponential for its rate. That raised to the t. What will the value be in 2 years? Our t value is 2. So what will the final amount be of that computer after 2 years, or what is y? We're going to put this into our calculator. Once again, make sure you do this first. Do the exponent and then multiply by 2,500. So 0.8 squared, 0.8 squared, that number you're going to multiply by 2,500. So if they wanted to sell this computer after 2 years, they can't sell it for $2,500. They could sell it for $1,600. So our value of the computer after 2 years, y equals $1,600. So they would lose about $900 if they tried to sell that computer after 2 years. That's what we have for problem number 4. Problem number 5, this one's kind of interesting. A cup of coffee contains 130 milligrams of caffeine. If the caffeine is eliminated from the body at a rate of 11%, how long will it take for 90% of this caffeine to be eliminated from a person's body? So when you drink caffeine in the morning, how many hours does it take for 90% of that caffeine to be out of your system? Well, it's going to be a decay problem because what's happening is your body is getting rid of that caffeine. It's eliminating it, which would mean it's exponential decay. So our initial amount, A value, is going to be, we start off with a cup that contains 130 milligrams. So 130 milligrams. Okay, the rate. It says that the caffeine is eliminated from the body at a rate of 11%. Per hour. So every hour, 11% of that caffeine gets eliminated from the body. So 11%, we would say it would be 1 minus 0.11, which is 0.89. So the rate of increase is 0.89. So it says how long will it take? So that's saying what is t? Okay, we want to find that variable t for 90% of this caffeine to be eliminated from the body. So I guess I ask you, class, what is 90% of 130? 90%, if you take 130 times 0.9, how long will it take for this much caffeine to be eliminated from the body? So 130 times 0.9, 130 times 0.9 is 1017. 1017. Did I do that right? Sorry, it should have been 130. 130 times 0.9 is 117. 117. So it's saying, how long will it take for 117 milligrams to be eliminated from this person's body? So what is my ending value? What is my Y value? Well, it is how much is left. If we started with 130 and the body got rid of 117, what's 130 minus 117? That is my ending value. And that number is 0.1, or 1/10. Sorry, what am I doing here? Sorry, class, I got ahead of myself in my notes. Okay, so 130 minus 117 is 13. So that is my amount at time t. So now I want to find out what t is. So here's my equation. Okay, so first, just like problem number 2, I first want to get this part all by itself. So let's get rid of the 130 by dividing both sides by 130. So now 13 divided by 130, there is my value of 0.1, or 1/10. That equals 0.89 raised to the t. So now at this point, to solve an exponent, I need to do a logarithm. Okay? So I have a log of 0.1, that equals the log of 0.89, and then this t could come out in front, so it's t times the log of 0.89. So what does t equal? Well, I can divide both sides by the log of 0.89, and that's how I get my answer. Log 1 divided by log of 0.89. The log of 0.1, oopsie, divided by the log of 0.89, I get an answer of 19, almost 20 hours. Just about 20 hours. So t is approximately 20 hours. So to summarize this one, what exactly are we saying? After 20 hours, hours, 90% of the caffeine is eliminated from the body. Cup of coffee stays in your system for a long time. This is kind of some food for thought, maybe some drink for thought for a lot of you in here who maybe consume caffeine in the morning. Next one, last one, problem number 6. Right out of college, you buy a condo. So picture this, class, in about maybe 6 or 7 years when you guys are out of college, you're going to buy a condo. It's $85,000. Just something to get you started. In 5 years, however, you plan to buy a house. So if you buy this condo and it increases in value, the condo appreciates, and let's say it appreciates at 5% per year. This is good for you. Your house is now worth more. Your condo is now worth more. What will it be worth when you sell it to buy a home? So what we're going to have here is we're going to have exponential growth. Okay? So with this growth problem, how much will it be worth in how many years? In 5 years. So you want to find Y when the initial amount of your condo is 85 grand and your rate of increase is 5%, so 1.05 raised to the t, which is 5 years. So if you bought it for 85 grand, how much can you sell it for 5 years later? This is going to be interesting. 1.05, raise it to the 5th. 1.05 raised to the 5th. That number times 85,000 times 85,000. You can sell it for $108,484 approximately. Okay? Just for the sake of numbers, making it easy for us. Let's put Y is approximately $108,000. $108,000. This is interesting to me because you really didn't, you didn't make any improvements to the home. You didn't really, make it a whole lot of better value. All you did was just live in it, but just the way the economy is at that time, it had a profit. You can make a profit if you sell it. That profit of being $23,000. That's the difference from here, from 108 to the 85,000. Okay, 108 minus 85 is $23,000. Just by living in that condo. Now what happens if it depreciates, class? That's bad for you because that means that it's going to get less. It's going to decay. You're going to lose money just by living in that condo. So it's going to be y equals the 85 grand is still going to be our initial amount. If it's going to decrease at a rate of 3% or depreciate, it's going to be 0.97. 1 minus 0.3 raised to the fifth. So if you sell it after 5 years when it depreciates, 0.97, raise that to the fifth power, you get a number, multiply that by 85,000. It's now worth approximately, I suppose that would be approximately 73,000. So let's put approximately 73,000. Y is approximately 73,000. And you might be thinking, what? How in the world did I buy it for 85 grand, but I can only sell it for 73 grand? You just lost, what would that be? $12,000. So this is a pretty big deal, class. As you're looking for a home someday, it's true what they say about location, location, location. If you could be in a spot where you could see the value of that land increasing in value over years and years and years, you might want to buy a home there because you're going to increase the property of your home. In the same way, if you get into a spot that's slowly declining, maybe a home or community that is losing people, so on and so forth, less people want to live there, your property is going to be worth less and less and less. So this is some thought for us as we proceed coming up in the future here on how we can use this in our real world lives. So what we have here is we have one last assignment. We have a worksheet on 10.6 that uses these exponential growth and exponential decay problems.